Okay, so we are in chapter 7, lesson 2, page 525, solve and write addition equations. Miniature golf. On the second hole of miniature golf, it took Annie 3 putts to sink the golf ball. Her score is now 5, and she represents this situation with cups and counters. So this box that's right over here represents her current score. Okay, and then over here is the cup. So her current score is 5. So you can see there are 5 points there. And the second hole, she got 3, so 3 putts. So that means that she had to hit the ball 3 times. So the cup is representing the score on the first hole, so the unknown score. So her score on the first hole is unknown. Okay, so the unknown part, we're just representing that with the cup. And then the second hole was these 3 points. Okay, so she scored 3 points. On the second hole. And then her score is now 5. So, so it was kind of multiple choice here too. So this is kind of a matching. Her score on the first hole is unknown. So that's the unknown part that's represented with the cup. Her score is now 5, and then she scored 3 on the second hole. Okay, so those are the 3 different pieces of the diagram there. So write the addition equation shown in the figure. So the addition equation would be 3 plus x equals 5. So, or you could say x plus 3 because the cup is first. So x plus 3. So that whatever's in the cup is x plus 3 more equals 5. Okay, so explain how to solve the situation, or excuse me, explain how to solve the equation. We would subtract 3 from each side, and let me show you how to do that with the counters. Subtract 3 from each side. Okay, so when we have this equation, Matt, where we have 2 things are equal to each other, if I have 3 here and I want to know what's in the unknown, what I can do is cross off 3 counters on the left side. But if I cross off 3 counters on the left side, I also have to cross off 3 counters on the right side. 1, 2, 3. So if I take away 3 from the left side and I take away 3 from the right side, they were both equal to begin with. So if I take away 3 and take away 3 from each side, they're still equal to each other. Okay, so that what that tells us is that this 1 cup, or x, is equal to 2 because we have 2 counters. So this tells us that x equals 2. So that means on her first hole, Anne scored 2 points. Okay, and in this lesson, we are going to learn how to do that with some word problems. Our learning target today is that we will be able to write and solve one-step equations. Okay, let's go ahead and turn the page to 526. Write and solve by subtracting. In lesson 1, you mentally solved equations. So chapter 7, lesson 1. Another way is to use inverse operations, which undo each other. So for example, to solve an addition equation, we will be using subtraction. So example number 1, we have 8 equals x plus 3. Okay, we're going to go down to the algebraic method first, and then we'll look at the counters method. So we had 8 equals x plus 3. Okay, so we are interested in finding out what x is equal to. X plus 3, what x plus 3 equals, we don't really care that much about. We want to know what x equals. So basically what we want to do is we want to cancel out this plus 3, okay, because we want the x all by itself. So to cancel out the plus 3, we subtract 3. We do the inverse operation. And the golden rule of algebra tells us whatever you do to one side of the equal sign, since they're both sides are equal, whatever you do to one side of the equal sign, you have to do to the other. So if I subtract 3 from the right-hand side, because my goal is to get the x by itself, then I also need to subtract 3 from the left-hand side. So -3. So these cancel out. I bring down the x, I bring down the equals. And over here, we have 8 minus 3, which is 5. So x is equal to 5. Okay, so that's how we solve the equation algebraically. And then we would do the check step. We want to check to make sure that our answer is true. So in our check step, we make a little check mark. We write the original equation, 8 equals x plus 3. And then the next line, to check that, all we do is where there is an x, we plug in or substitute in a 5. So bring down the 8, bring down the equals. Instead of x, we're substituting that with 5, bring down the plus 3. Okay, next line, we just bring down the 8 equals, and then we actually add these together. Okay, so we add these together. What is 5 plus 3? 8. And then once we see that those two sides are equal, we know that the x equals 5 is our correct answer. The check mark at the beginning and the check mark at the end just lets me know that this is not part of that equation solving. This is my check step to prove that I have the correct answer. Now, I know that you can do this in your head, 5 plus 3 equals 8, but we're building good habits with how to show the check step because we will start working with equations that you can't do in your head, and we want to be able to use the check step appropriately. Okay, we're going to look at method 1. So method 1 is with the counter, so physical model, so you can draw. Here's the equation, 8 equals x plus 3. Okay, so the equal sign is in between the two sides, and this is represented, so the 8 is here in this white box. The equal sign is here in between the two white boxes, and the x plus 3 is on the other side of the equal sign, which is represented by everything inside of this white box. So the two sides are each represented with their own white box. Okay, 8 is represented with 8 counters, 1, 2, 3, 4, 5, 6, 7, 8. The equal sign is the equal sign, and that goes in between the two white boxes. And then we have x plus 3. So x is the cup, that's the unknown. Okay, you can label it x if you want. And then the 3 counters are this. So the physical model, to cancel out these 3, we subtract 3 algebraically. That's what we just did in method 2. Take away 3 from each side. So when we're showing that with the physical model, take away 3 from each side, we cross them off, cross off 3 counters from the right-hand side. But in order to keep them equal, whatever I do on the right-hand side, I also need to do on the left-hand side. So I'll cross off 3 counters on the left-hand side. Okay, so what am I left with on the left-hand side? I have 5 counters. And then what am I left with on the right-hand side? X. So we have just x and we have 5. So x equals 5. Okay, so that's how we can show that with a physical model as well. Okay, let's look at example A at the bottom. Okay, example A, we have c plus 2 equals 5. So again, we're interested in solving for c. We don't really care what c plus 2 equals. We care what c equals. So we want to cancel out this plus 2. So to cancel out a plus 2, we use its inverse operation, which is minus 2. So we always line up numbers with numbers. Okay, and that'll be really helpful for us, especially when we get to multi-step equations. Right now, we just have one-step equations, just minus 2, just one step. Okay, so we always line it up underneath, numbers under numbers. And then whatever I do to one side of the equal sign, I did minus 2 on the left-hand side of the equal sign. So I also need to do minus 2 on the right-hand side of the equal sign. So over here on the left-hand side, 2 minus 2 is 0. So when this cancels out at 0, so c plus 0, you don't have to write that 0 there, but C plus 0 would just be C. So we can draw a slash through these because they are going to cancel out. So C, and then 2 minus 2 is 0. 2 minus 2 is 0. So that's nothing. C plus 0 would just give us C. Then I bring down the equal sign. And then 5 minus 2, 5 minus 2 is 3. So our answer is C equals 3. And you box your answer. You can use that equal line as the top of your answer box if you wish. Next, letter B, we have 6 equals x plus 5. We're not interested in what x plus 5 equals. We're interested in what x equals. So we want to isolate the variable x. We want to get the x all by itself. So we want to cancel out the plus 5. To cancel out the plus 5, we subtract 5. Okay. 5 minus 5 is 0. So on the right-hand side, we just have x remaining because x plus 0 would just give us x. Bring down the equal sign. And then 6 minus 5 is 1. So x equals 1 or 1 equals x. And I forgot to do the check step with you. So let's do the check step right here. If you can't fit it in here, you have lots of room over on the left-hand side of your page for workspace. So you can write that there. I'm going to do the check step for A right here. Our original equation was C plus 2 equals 5. C plus 2 equals 5. And I write a check mark at the beginning of that equation so that it's obvious where the check step is starting. Okay, so C is equal to 3. So we have 3 here. Bring down the plus 2, bring down the equals 5. Okay, on the left-hand side, we add these two terms together. 3 plus 2 is 5. Bring down the equals and bring down the 5. And then once we end up with the true statement, 5 equals 5, we are finished with our check step. Okay, and we can put the check mark there. All right, let's check B. Okay, letter B, I'll check right here. Our original equation was 6 equals x plus 5. 6 equals x plus 5. Okay, and then we said that the answer was x equals 1. So we're going to take that 1 and we're going to plug it in here for x. So bring down the 6 equals, and instead of saying x plus 5, we're plugging in a 1 for x. So we have 1 plus 5. Bring down the 6 equals again. Add these like terms here. 1 plus 5 is 6. So 6 equals 6. And that's the end of our check step. Let's do letter C together. So we have 3.5 plus y equals 12.75. So again, we're not interested in what 3.5 plus y equals. We're interested in what y equals. We want to solve for the variable y. So we do not want this 3.5 here. First of all, we want to really be careful. We see that this 3.5 is a positive 3.5. A positive functions like a plus. So we want to cancel that out. We're going to subtract 3.5 because that will give us 0. So 3.5 minus 3.5 will give us 0. That's the reason that we're subtracting 3.5. The identity property of algebra lets us do that. Whatever I do to one side, I also do to the other. As long as I decrease both sides by 3.5, they remain equal. And I can start simplifying this equation. So the left-hand side, I subtract 3.5. And remember to line up your decimals when we're subtracting or adding decimals. On the right-hand side, we also need to subtract 3.5. Okay, so we line up our decimal. On the left-hand side, 3.5 minus 3.5 is 0. So this cancels out. Then we have a positive y. So I'm just going to bring that down, or a plus y. I don't need to bring down the plus sign or the positive sign. I can just bring down the y, bring down the equal sign. Okay, and then I'm going to line up my decimal, line up the decimal. Okay, so we subtract from right to left. There's nothing here. So 5 minus nothing is 5. 7 minus 5 is 2. 12 minus 3 is 9. So y equals 9.25. And then I want to do my check step. So I write my original equation, 3.5 plus y equals 12.75. And then where the y was, I'm just substituting in 9.25. So I'll say now 3.5 plus 9.25 equals 12.75. Okay, Now I want to add on the left-hand side. Okay, so this would be like 50 cents. This would be like 25 cents if you think of it as money. Okay, so 50 cents plus 25 cents will be 75 cents. Here's my 0.75, and then 9 plus 3 is 12. Bring down the equal sign, and then bring down the 12.75. And you can also, if you don't like adding horizontally, you can always come over to the side and add vertically. So you could write 3.5 and add 9.25, and you could add vertically if you prefer to add vertically. Okay. But anyway, back to the check step. We have 12.75 equals 12.75. So we know that we did that is the correct answer. Then we put a check mark to show that that was the end of our check step and that we did take the time to check our answer. Okay, so let's do a few more examples with subtraction property of equality. So the subtraction property of equality tells us if you subtract the same number from each side of an equation, the two sides remain the same. So that golden rule of algebra, whatever you do to one side of the equation, you also have to do to the other, is what allows us to manipulate. So if you had 5 equals 5 and subtract 3 from each side, you end up with, start with a true statement, follow that subtraction property of equality. You get 2 equals 2. That's another true statement. So if you have example with an algebraic example, you have x plus 2 equals 3. If you subtract 2 from each side, you get x equals 1. Okay, so then it helps you to solve the equation for the unknown. When you solve an equation by subtracting the same number from each side, you are using the subtraction property of equality, or in my generation, we would call this the golden rule of algebra. So it kind of summarizes all of the different properties of algebra. Okay, let's do example D down here at the bottom. Suppose Ruben had 147.5 minutes of the 245.5 that were downloaded. So write and solve an addition equation to find out how many minutes belong to Tariq. So it looks like we'll just read example 2. We don't have time to do both, but we'll read example 2. Ruben and Tariq have downloaded 245.5 minutes of music. So 245.5 minutes of music, and that's down here in this problem as well. If Ruben had 130, so this is just the two different people. So we have Ruben and Tariq. Okay, so presumably they're friends who are downloading some music. Maybe they're making a video. Okay, so if Ruben had 147.5 minutes of the total 245.5, write and solve an addition equation to find out how many minutes belong to Tariq. So Ruben plus Tariq equals the total number of minutes. Okay, so that's kind of our general algebraic expression. So Ruben's minutes plus Tariq's minutes equal the total number of minutes. So that's the equation that we need to write. So we have a little bit more space over here. Let's work over here. So they said, suppose Ruben has 147.5 minutes. So instead of saying Ruben plus Tariq, we're going to say Ruben. We're going to put Ruben's here. So 147.5, this is Ruben, plus Tariq's minutes. I'm going to do minutes, M-I-N, equals, I'm off my chart, I'm sorry. So Ruben's minutes plus Tariq's minutes equal total minutes. Okay, so they told us that Ruben has 147.5 minutes, and the total was 245.5 minutes. So we'll say 147.5 plus Tariq equals the total, which is 245.5. So we want to isolate the variable to find out Tariq's number of minutes. So we want to, this is a positive 147.5. So we want to subtract 147.5. And the golden rule of algebra, or the subtraction property of equality, is whatever you do to one side of the equation, you have to do to the other. So if you subtract 100, if they're equal, which they are because we have an equal sign, if you subtract 147.5 from one side, you also have to subtract 147.5 from the other side so that they remain equal. So it's like this balance. Okay, so 147.5 minus 147.5 is 0. We know that, and we did that intentionally. So on the left side, we just have that positive t, which is what we want, Tariq's minutes. Line up the decimal. Okay, and then we go ahead and subtract. 5 minus 5 is 0. Okay, we need to regroup from over here. We have this is, well, we can also see we can, this is going to be 98 because 245 minus 147 will give you 98, but you can regroup and borrow if you need to, but you can see they're 2 apart and 100 apart, so 98. So Tariq downloaded 98 minutes, so T equals 98. Tariq has 98 minutes. Okay. And then we can check that by adding these together. So here's our check step. 147.5 plus T equals 245.5. Okay, so then we substitute in, we're checking the 98 for T. So 147.5 plus 98 equals 245.5. And we add these together, and I am going to add vertically here. So 147.5 plus, line up your decimal, the 98 is our whole number. We end up with, this is 98.0. Okay, 7 plus 8 is 15. Write the 5, carry the 1. 9 plus 1 plus 4 is 14. Write the 4, carry the 1. So we get 245.5. So 147.5 plus 98 was 245.5, which makes the left side equal to the right side. Okay, so that is just a check step to show that Tariq does have 98 minutes. So that was chapter 7, lesson 2.